Okay, in this video we're going to look at drawing and naming ketones, carboxylic acid, and esters. So in our ketones, the first one that we're going to look at, the functional group contains a carbon, double bond O. That functional group is called a carbonyl side group. And you can see that's attached to two alkyls either side. So it's similar to our aldehydes, which was always at the end, and always ends with a H, which was carbon double bond OH. But this time the carbonyl group can be anywhere along the alkane chain. So when we do draw them and we do name them, depending on how long the chain is, we're going to have to signify where that functional group is. So here we have it. Again, we're going to look at the molecule and see what functional group it is. So now I can see that it is carbonyl. It's not ending on a hydrogen. There's an alkyl group either side of it, so it's a ketone. Ketones end with ONE. So you're going to count the number of carbons. We've got 1, 2, 3, 4. 4 carbons. So in this molecule, it can only be on carbon 2. Okay, even if this molecule is flipped around, so if I redrew it, and we're going to move the carbonyl group over 1, it's just the exact same, it's just a mirror image of it. Again, carbon 2. So it can't be at the very end of the molecule, it has to be within the middle of it. So now naming this, we've got 4 carbons, so we're going to go for bute, and it's going to be called butanone. So before I fill in this one now, we have 5 carbons here. The carbonyl group could be on this carbon, or this carbon. So in this molecule we have a choice of them, but in this example I'm going to actually place it here, and I'm going to saturate the rest with H's. So because we had a choice of carbons there, it's important in this one to give the label of where that functional side group is. So we're going to label it giving the functional side group the smallest number. So we've got 5 again, so it's going to be pentanone. We're just going to label it 2-pentanone, so that we're signifying where that carbonyl group actually is. So now this is a slightly different molecule. You can see it's in a cyclical structure. So again, we're just going to look for our functional group. You can see that it's here, and it's connected down to 2 alkyl side chains. So it's not an aldehyde, it is going to be a ketone. Now, we're going to give the numbering system this carbon here, number 1. Now, depending on which way to go, should we number this way or number this way? So we're going to check if there's any other side groups, which there are. We can see that there's 2 chlorines here, and we have an iodine here. So if we number it this way, 1, 2, 3, that's going to give our first side group the smallest number. If we went the opposite way, 1, 2, 3, 4, then our first side group, which is iodine, is going to get the number 4. So we're going to go with our original way, 3, 4, 5, 6. So this is a ketone because of our functional group, and there's 6 carbons, so it's going to be a hex, but it's going to be a cyclohexane. We're going to end it with an ONE, so cyclohexanone. Now we do need to talk about the side groups. So the 2 side groups in present here are chloro and iodo for the iodine. So you're going to take a look at which one comes first in the alphabet. So it's chlorine, and we've got 2 of them. Let's use a different colour. On carbon 3 and an iodine on carbon 4. So we're going to go 3, 3, because there's 2 chlorines on the third carbon, dash. We have 2 of them, so we need to say dichloro, dash again for the next side group, 4, dash iodo, cyclohexanone. Okay, we're going to look at carboxylic acids now. So again, this is going to be a terminal to a molecule always. So we have, unlike our aldehydes, we have an OH at the end. And it's going to end in our naming system with oic acid. So if we have a molecule here, we're going to look at the functional group. It is a carboxylic acid. So I'm just going to name it 1, 2, 3, 4, 5. It's 5 carbons, so it's going to be pentanoic acid. Easy enough. So we're just going to go and do a slightly different one. We're going to take out some of these normal hydrogen side groups and make it just a small bit more difficult to name. So we're keeping the basic structure the same. So there is still 5 carbons and it still has the same functional group. So we're going to end it on pentanoic acid still. We have just a few more bits to talk about. So we have a few side groups, 2 chlorines and a methyl side group. So look at chloro, look at methyl. Chlorine comes first, so we're going to put that first. C comes first in the alphabet. So we've got 2, 2, dichloro, and then we have 3 methyl pentanoic acid. Okay, lastly now we're going to look at esters. So we have again a carbonyl group, but we're going to have another oxygen in the main chain connected to an alkyl side group and another alkyl side group. So I'm going to quickly draw one in. These all end with OATE. Okay, so we're going to have 3 carbons, an oxygen and another carbon. So if you look at this molecule, again you can see there's an alkyl side group here and another one alkyl side group here. And then we have in the middle this kind of bridging effect. So what I do is I'm just going to use the oxygen that's in the main chain as our separation guide between the 2 alkyl side groups, because we do need to consider this carbon in here as well. So the oxygen separates out the 2 alkyl side groups nicely. So you're going to look at the one that contains most of the functional group first, so this side, and you're going to count the C's. So there's 3 C's, 1, 2, 3. So that is going to be propan OH. But of course we do need to take in this side as well, which is 1C, which links with meth. So this is going to be actually methyl propanoate. So you split up this molecule into 2 sides. The one that contains most of the functional group, and then this side. Okay, so if you want to try and pause here and try and name this one. So again, we're going to create our bridge just around the oxygen on the main chain. So we're going to name this one here first, that contains most of our functional group. And we have 2 C's, so that's going to be F. So it's going to be ethanoate. And then of course we need to talk about this side, which is an ethyl group. So it's just going to be ethyl ethanoate. Okay, and this is our last one. So do you want to pause here and try and name this one as well? Again, we're creating the bridge around our oxygen. Naming this side first. That contains most of the ester functional group. We see there's only one carbon, so it's going to be methanoate. And then this side contains 1, 2, 3, so it's going to be a propyl methanoate. And that's it for naming ketones, carboxylic acids, and esters.